boys and girls? It's your main math man, Mr. Shang, coming to you live from Alameda International High School. In this video, we're kind of summing up the entire semester, first semester one. We're going to cover some topics on and in preparation for our final. So make sure you can see how this works. Again, I'll break it apart one page at a time, so each video will have its own page. So on this first page, we're talking about some sequences, and so make sure you're understanding what a sequence is in general. Again, a sequence is just a list of numbers. Kind of looks something like this, where it has that comma, and then those terms are going to be those values. Anytime you think of an arithmetic sequence, you're talking about adding values. So make sure you're saying, okay, arithmetic is adding. So that means that I'm going to add the same number, meaning the common difference, each time to get my next term. Make sure you can use those general formulas, and then you'll come up with each of those terms. So again, make sure you're thinking, anytime I have an arithmetic sequence, this is going to be my general formula. So I have u sub n is equal to, I have the first term plus, and then I have n minus 1 times my common difference. So make sure you're plugging it in like that with those parentheses to show multiplication. So now I can say, okay, I have my formula, what can I replace it with? Well, I know that u1 is going to be 12, since I have my first term as 12, and my common difference, d, is going to be 8. So again, I plug these in, so I have u sub n is equal to 12 plus, and I have n minus 1 times 8. Make sure you can simplify, so I need to say, all right, anytime I have those parentheses, that means multiply, and so on the side here, you can kind of have this distributive property, so that way you know you're good. So what I do is I write the terms inside the parentheses, I write those on top, and then I write the products inside the boxes. So I do 8 times n is 8n, and I have positive 8 times a negative 1 is going to be negative 8. And then what I can do is I can write it below. So I have un is equal to 12, and I have plus 8n minus 8. Again, this is where a lot of mistakes are made, because people don't multiply correctly, or they kind of skip that step and hope for the best. Again, make sure that you are taking your time on that step. So now we can combine like terms. So I have 12 minus 8 is 4, and so that means my general formula is going to be 8n, and then I have plus 4. So again, it should be in that form where I have whatever value it is plus 4. So for example, if I said, and I can always check too, I can say, hey, well, what is going to be my first term of this sequence? I can plug in n equals 1, and I would say 8 times 1 is 8, plus 4 is 12. So we know we are good. So always double check to make sure you're good. In the second one, it says the first 4 terms of the sequence are 5, 16, 27, 38. So if you're ever unsure how to get your common difference, again, this is only for arithmetic sequences, but you can say common difference is going to be equal to the second term minus the first term. Again, make sure you can always check to make sure you're just adding by that same number. So if you're able to identify, hey, I'm adding by 11 each time, then that's good. But I can say, well, I have 16 minus 5 is going to be equal to 11. So I have my common difference is 11, and my first term is 5. So again, take that formula. I have un is equal to the first term plus, and I have n minus 1 times d. Again, plug in those values for variables. So I have un is equal to, let's have 5, I have plus n minus 1 times 11. So I'm going to say, all right, use that distributive property. I have 11 times n and a negative 1. That means I'm going to have 11 times n is 11n, and 11 times a negative 1 is negative 11. I can write that underneath, so I have un is equal to 5 plus, and then I have 11n minus minus 11. Make sure you can combine like terms. Again, since there's no other variable terms, the 11n stays the same, and so I'm going to say, all right, I have un equals 11n. Make sure you can subtract, so I have 5 minus 11 is going to be negative 6. Again, if you need to, please use that calculator for yourself. Again, if you need to have 5 minus 11, just to double check to make sure you get your values correct, please do. So again, anytime it's asking for that general formula, it will look like that. Again, you're trying to simplify for your sequence un. So now it says, for this next part, it says solve for find the given term for each arithmetic sequence. So in this first one, it says solve for the 28th term of the sequence given by this formula. So it has un is equal to 12n minus 9. So this is your general sequence. You take that value of 28 and we're saying, hey, what is that 28th term? So we can say, all right, let's let n equal 28, and we plug it in. Plug it in. So we're gonna say, all right, u sub 28, so anywhere where I have an n, I now have 28. So I'm saying the 28th term is gonna be equal to, I have 12 times 28, and then I have minus 9. Again, if you want to, you can type this into your calculator right away, but I wanna make sure I'm doing this correctly, so I can say, all right, 12 times 28 is gonna be 336. Then I have to bring down that minus 9, I'm gonna say that my 28th term is gonna be 327. And so how can I check that using the calculator? So again, that was pretty simple, but I wanna make sure that I can find any term in that sequence. So let's do it like this. Let's say I hit y equals, bring up my functions, and I can type it in exactly as it looks. And except now I'm gonna say, all right, un is y, and then this right side is gonna be my function. So I can just say n is just x. So what I can do, type it in as it looks. I have 12x minus 9 as my function. I want to find that 28th term, so I hit second graph to get my list of values. Make sure you can have your change in your table be 1. And so, all right, let's do second window. I want to start my table at 28, so that way I go directly to it. Again, you can also scroll up and down on that table. I can say, all right, hey, 28th term, meaning x equals 28. I can see whatever my y value is going to be that output. So I'm saying the 28th term is going to be 327. So we know we're right, again, without any calculations, super simple. All right, so the next one, similar idea. It says solve for the 30th term of the sequence, and it has un is equal to 8 plus 7n. So let's see, let me type it in as it looks. So I have 8 plus, and then I have 7x. I can hit second graph to get my table, and I want to go to where x equals 30, and so I should get an answer of 218. So let's see how this works. So again, I say let n equal 30 and plug it in. So I have u30 is equal to 8 plus, and I have 7 times 30. So I'm gonna have 7 times 30 is gonna be 210. So this is equal to 8 plus 210, which is going to be equal to 218, which is what we said in the first place. So again, double check, we know we're good. So my 30th term in this sequence, specifically, almost got tongue-tied, is going to be 218. All right, so again, anytime you're thinking of arithmetic sequences, make sure you can think of adding by the same number. However, if you have, let's say, geometric sequences, you can say, hey, I know I have to be multiplying. So I'm going to be multiplying. I'm going to be multiplying by that same value each time. If you're thinking of your values getting smaller, meaning my sequence of numbers is decreasing, that means that my common ratio would be, a fraction or, a small decimal value. So make sure you're kind of using those ideas. Again, those geometric sequences are going to be just like our exponential functions. So all right, it says write the general formula for each geometric sequence. So similar idea, same steps. We have to identify the first term and our common ratio. We use our general formula, which is going to be different than the arithmetic sequences. So in the arithmetic sequences, we said it was adding. However, now we have to make sure we are multiplying. So we have, this is going to be U1 is 12. We have our common ratio R is going to be 4. Then what we can do is we can say, all right, we have our general formula, so we write out our formula. We have UN is equal to, we have our first term U1. I write it in parentheses to show multiplication. And then I have our common ratio R, and then make sure this is in the exponent. I have R to the exponent, or to the power n minus 1. So make sure, notice how it's kind of similar to our arithmetic sequence formula, but we are multiplying, and that exponent is going to be the differences. So now I have my formula, I substitute in my values for my variables, and so I say UN is equal to, I have my first term, which is 12, my common ratio, which is 4, and then I have that exponent n minus 1. Again, this is super simple for those geometric sequences. Again, if you're asking for that general formula, all you have to do is take and substitute those values in, and you are done. So this would give you any term in that sequence. All right, so now if it gives you a list of numbers, you know that's that sequence, and it says the first 4 terms of this geometric sequence are the following. So it has 1/4, 1, 4, and 16. So now you're thinking, okay, what am I multiplying by each time to get my next term? If you're ever unsure or you are stuck, you can say, hey, my common ratio is going to be my second term divided by my first term. Again, make sure you can say that is going to be your common ratio. Notice how it's a ratio meaning a fraction. So what I can do is I can take and say, all right, well, I know U1 is 1/4. My second term is 1. So what I can do is this. I can say, all right, I have my second term, which is 1, and I can say it's divided by, well, what's my first term? It's 1/4. We can also write it as a decimal, so I'd say 0.25. And this will give me my common ratio. So this would be, so this is what I did. I said R equals, I had 1 divided by 0.25, and I would say R equals 4. And that makes sense because 1 times 4 is 4, 4 times 4 is 16. So I have to be multiplying by the same thing each time. That's that key part. Arithmetic sequences, you add the same number each time. Geometric sequences, you multiply by the same number each time. Now that we identified our 2 items that we need, we can write our general formula and substitute. So I have UN is going to be equal to first term times our common ratio to the power n minus 1, and I substitute in my values for my variables. So I have UN is equal to, I have 1/4 as my first term, and my common ratio is 4. So I have that to the power n minus 1. So again, make sure if you're ever unsure what that common ratio is, again, it's that second term divided by the first term. Underneath of that, it says solve for the given term for each geometric sequence. So similar idea as before. Again, we take that value for n and we plug it in. So we're saying let n equal, let's say, 9. So let me actually read the problem. It says solve for the 9th term. term of the sequence with a formula, and it has un is equal to 1 over 16, and then it has times 4 to the power n minus 1. So again, just take this value for n and plug it in. So it should look like this. Again, we would have u9 is equal to, we have 1 over 16, and we have 4 to the 9 minus 1 power. So all that we did was we took and let n equal 1, and we plugged it in. So anywhere where we have an n, we now have a 9. And what I can do, you can evaluate this, taking one part at a time, or keep it simple for yourself, type it in exactly as it looks. So I'm going to say, all right, I have 1 over 16. Again, that's 1 divided by 16. If you want to type a fraction, you like seeing how fractions look, I can say, all right, let's have my fractions. What I do is this, I hit alpha y equals 1, and it will give me a numerator and a denominator. Again, use those arrow keys to move around, but as long as you can have that, you'll be good. So I have 1 over 16 as my fraction. That's going to be my first term. And then I can say, all right, I have 4 to the power, so make sure you hit the exponent button. Again, that's right below the clear button. I hit exponent. Notice how my cursor is in the superscript, meaning the exponent. And so I'm going to say not n minus 1, I'm going to have 9 minus 1. Again, be very mindful when you're hitting these buttons. Again, this is a negative sign, this is a minus sign. So be very careful when you're hitting those buttons, as you will get different values. So again, as long as I type it in exactly as it looks, I'll get my answer. So I'm going to say my 9th term of this sequence is going to be 4096. How can I check to make sure that it works, or how can I check to see if I have any other values? So I'm going to say, all right, I type in y equals, type it in exactly as it looks. So I hit, let's have parentheses, I have alpha y equals 1, I have 1 over 16, and then I have 4 to the exponent x minus 1. So if this is my function, again, I can go to that table of values. So I hit second graph, and I want to go to where it has x equals 9, because that's going to be my 9th term. So again, I can just scroll up on the values of x. So again, these are going to be the number of the term. And so I'm going to say, all right, when x equals 9, meaning my 9th term, that's going to be 4096. So again, another way to double check your answers is what I just showed you. All right, so let me clear this out. On the last one on this page, it says find the 7th term of the sequence with a first term of 1 and a common ratio of -3. So that means we're multiplying by -3 each time. So let me write my general formula first. So I have un, I have my first term, which is 1, and I have my common ratio, -3 to the power n minus 1. So that's going to be my general formula. Again, take and say n, let n equals 7, plug it in. So I have u7 is equal to 1 times, and then I have a -3 to the power 7 minus 1. Type it in exactly as it looks. So I have 1 times a -3 to the power 7 minus 1. Hit enter, and we know we're good. So we have, let's have u7 is going to be equal to, that means my 7th term is going to be 729. Make sure, again, you can have each of those values in there as you substitute and simplify. If you're stuck on a question and you say, well, how can I double check? Again, type it in as it looks. So I have 1 times -3 to the power x minus 1. I hit second graph to get my table of values. What you can do is this. I can check to see, I have my 7th term is going to be 729. You can make sure if you are looking to see if a term is in the sequence, meaning something like this. Let's say is 81 in the sequence, meaning is this value a term in the sequence? Well, what you can do is you can look on your list of values and you're saying, okay, well, my x values are going to be the number of term. However, the y values are actual terms in the sequence. So I have -3, 9, -27, and there's a number 81. So we'd say yes, and then we'd say it's the 5th term. So again, make sure you can plug those in, double check, and as always, super slam that subscribe button.